SwayamPrabha. Digital India. Educated India.
Welcome viewers to the fourth lecture of the open online course on metal cutting and machine tools. So, in the last lecture we made some discussions on the relationships existing between different angles of the single point turning tool in different systems like the orthogonal rake system, the machine reference system, the normal rake system, and that too we did not only restrict our discussion to the rake surface, but we also discussed I think one example from the clearance surface. Okay. The clearance surface means that the tool is bounded on three sides by three planes. One is the rake surface, one is the principal flank or side, and the other is the auxiliary flank. So, we established some relationships between the angles in the principal flank and the inclination angle. The inclination angle is shared between the rake surface and the principal flank. So, in these calculations we are generally assuming that some angles that we have shown, they are positive. Okay. Now, coming back to our discussion, let us now take up the problem of the last discussion that we left behind. So, for that this was the particular problem that we left behind, that you could solve it yourselves. Let us look at it once again. The main trick that we discussed in these problems is that to identify the particular triangular relationship between the vertical distances that we go down in different planes, and that we establish the relationship between angles. Here we are saying that as we go down from this point very near to the cutting point down the main cutting edge, it is shown here this way. We are coming down the main cutting edge in this view. For that we are incurring a vertical distance, okay, downwards. We are having to move downwards by this vertical distance. What is this vertical distance equal to? As we discussed before, it must be equal to L tan lambda, and that is why we write L tan lambda here. So, we get L tan lambda as the vertical distance down, as shown here. After this we are getting, just a moment, after that we are getting down further along the orthogonal plane by this distance O. What is O equal? What is the vertical distance corresponding to the movement along O? It must be equal to O tan gamma O. Sorry, I am sorry. We are not discussing about the rake surface anymore. We are going down by this distance as it is shown by a dotted line along this line. Okay. We are going down. Let me use the pen. We are going down, and a suitable ink now is this black. Let us see. We are going down this way. If we go down this way, so once again from the cotangent relationship that we had established last time, the vertical distance that we go corresponding to O must be O cot alpha, and that is why let us again underscore it, O cot alpha O. That means O into cotangent of the orthogonal clearance must be the distance we are going down this way. that is fine. So, this must be equal to the distance that we are going down in the transverse direction along the clearance. Okay. So, this is the, let me use a different color once again, say which one, this perhaps. Okay. This is the distance that we are going this way, and this is the corresponding downward distance, and therefore, since alpha y is here, that will once again be equal to b cot alpha y. I am sorry, this is slightly covered, please just imagine that there is a y here, not shown very clearly, I am sorry. If that be so, once again we identify that b being the hypotenuse, we can divide this by b, cancel, and therefore, we have tan lambda multiplied by L by b. Now, what is L by b? Phi being equal to this, okay, we understand this must be phi. Oh, sorry, this is 90 minus phi, and therefore, this is equal to phi. This is phi. This is phi. If this is phi, then L by b must be equal to sin phi, and that is what we have here, sin phi. So, we are replacing here sin phi. O by b must be cos phi, cot alpha comes here. So, term by term we are simply just repeated, and this is the relationship we get. Alpha y, alpha o, and tan lambda can be related this way. So, we have established a relationship among angles, among the clearance angles for the main or principal flank, okay, in the orthogonal plane, the machine transverse plane, and the cutting edge, main cutting edge. Okay. Okay. Now, let us move on to the next problem that we have. Just one moment. So, we will take the cursor, a new view, and let us move on to the new problem. What does this one state? Just like we established a relationship between machine transverse plane, we can also do it for the machine longitudinal plane. Machine longitudinal plane here in this expression is represented in this direction. Okay. So, what are we doing here? We are saying that if we start from a particular point, if we go down along this and along that, it is the same as going down this way by this amount. Therefore, if lambda is shown to be positive, we go down here. If this alpha o is shown here as positive, clearance angles have to be positive anyway. So, we go down along this, and therefore, it must be b cot alpha. Now, that you have got the hang of it, you can move very fast. So, it must be L tan lambda. We have to be alert about this. This is tan, while this is sorry. This is tan, while this is cot. So, L tan lambda plus b, as we are moving in the clearance surface now, b cot alpha x must be equal to O cot alpha O in this plane here, cot alpha O. You will find that this triangle that I am drawing and in the figure, they might not exactly correspond drawing wise. So, please understand that I am not strictly following the drawing rules and principles and traces, etc. So, let us move right away in the same method that we have taken up before, L by b, b by b, O by b, that is it. We get cot alpha x equal to, tan lambda into what is L by b, let us see. This must be our phi, and therefore, L by b is nothing but cos phi. So, that is why we get cos phi, tan lambda cos phi plus cot alpha x is equal to sin phi into cot alpha O. All right. So, this one helps us in relating the what do you call it, inclination angle, the clearance, the side clearance of the main cutting edge of the principal flank, and orthogonal clearance in the principal flank. So, in this one what do we have? Now, we move on to the auxiliary flank. Up till now we have been discussing problems on the principal flank and of course, the rake surface. Now, we go to the auxiliary flank. In the auxiliary flank, what are we trying to establish? First of all, we have shown the sections that we are going to obtain here, that this section is perpendicular to the auxiliary cutting plane. This is the trace of the auxiliary cutting plane. Okay. This is what we see in the auxiliary cutting plane, lambda dash, auxiliary inclination angle. You might say, why are we giving the inclination angle at all? We could have kept it to be 0. Generally, whatever rake angle we are using, if we give a positive rake, it will help us in reducing the forces and facilitating chip formation. Higher the rake, positive rake angle, less will be the change in momentum of the chip coming out, and therefore, less will be the forces. Then comes the question, then why do not you use huge positive values of the rake angle? That is because in that case the tool will become very weak. Even if it does not break, it is likely to bend as a cantilever, which will reduce our accuracy, and therefore, rake angles are generally restricted to not more than 15 degrees, and more frequently it is 5 to 7 degrees. Okay. So, we use small values of rake, but if we can use positive rake angles, it will help us in facilitating chip formation and reducing forces. Do we ever use negative rake angle? Yes. Whenever we want the stresses occurring on the rake surface to be purely compressive, in that case, I mean, if the stresses created by the chips impacting on the tool or applying pressure on the tool, if we want this pressure to be not if we want this pressure not to create tensile forces, then we will try to use negative rake. Negative rake ensures that there will be no tensile forces on the tool body. That is because generally the materials which make up the tools, they are strong in compression and they are weak in tension. Okay. So, in that case, if we apply tension, they will break very easily. If you use positive rake, it can be shown that they are likely to develop tensile stresses inside them and by bending as a beam. This we will be discussing later on. Coming back to our present discussion. So, let us take up a problem in the on the auxiliary clearance angles. What are auxiliary clearance angles? So, you might say that if you are talking about the auxiliary cutting edge and the auxiliary flank, then how come we have not discussed about auxiliary rake angles? This is a very pertinent question. Yes, auxiliary rake angles should have been discussed and we should have established relationships between those angles etc. But you know, there's a particular limit to what we should discuss in tool geometry. There's no end of it. Since this is only a 10-hour lecture course, so I will be giving you the basic essence, and I am sure that with the knowledge that you acquire here and the confidence that you will be having, you will easily be able to establish relationships between, say, auxiliary orthogonal rake, auxiliary transverse rake, or auxiliary side rake, relationships between these angles. Okay. We have yet another class in which we are supposed to discuss the 5th lecture. That means, the one directly after this, we are supposed to discuss numerical problems. So, there I will take the opportunity to discuss some problems in which we have not made any earlier discussion. It will both give you you know, the experience of solving for the auxiliary rake angles, and it will help us in solving numerical problems also. So, coming back to this, now we are discussing about the auxiliary cutting edge and the relationships between the inclination angle and the clearance angles in that plane. So, when we are considering this particular triangle, we are saying that suppose I am going down the auxiliary cutting edge, then what is going to be the relationship existing between these vertical movements downwards? If you see the auxiliary orthogonal plane, from this point we are moving down, and from I have not drawn the what do you call it, the auxiliary side rake, auxiliary clearance. We can draw it here itself. Let me take this opportunity to draw it. That is, if we move from here, this is the point of cut. If we move upwards, we can draw this section of the tool, and this will be our auxiliary side clearance. Okay. So, if this be our auxiliary side clearance, therefore, we are moving down this way. Sorry, once again I made a mistake. We are going to move this way down. Let me draw that also. This is our downward, it shows our downward movement. So, we are moving down this way, we are moving down this way, and we will say that the amount that we have moved down here and the amount that moved down here should be equal to this total movement. Okay. So, let us start. This one is again L tan lambda dash from our previous experience. Okay, L tan lambda dash. What extra movement are we executing here? This must be equal to B cot alpha x dash, B cot alpha x dash. Okay. Sorry, sorry, this one should be B cot alpha x dash. Do we have it correctly here? If we are going down from this point, reaching this point, we can also go down this way and that way. Okay. So, we are, or we can do one thing, if we are going down from this point, but we are moving up here. I think there might be an issue at this point. Let me have a look once again. L tan lambda dash is this distance, and then I move further down along this one. I move further down along this one. So, this is equal to this expression. So, I will do one thing, I will introduce one negative sign here. Okay. So, that it is L tan lambda dash plus this one, and here also I introduce a minus sign here. So, basically A plus B is equal to C. If that be so, let us see what the expression of cot alpha dash x comes out to be. Cot alpha dash x, if we take it to this side alone, in that case first of all b is divided, I mean b divides this and this gets cancelled out, and what we will have is that if this is coming to this side, cot alpha o dash will be positive and this one will be negative. So, please bear with this particular change. Okay. I will write the proper equation here. This one I cancel out and I write L, okay, tan lambda dash minus a plus L tan lambda dash plus b cot alpha dash x must be equal to O cot alpha dash O. This is the relation that we are talking about. If this be so, then O cot alpha dash O, this one is, everyone is going to be divided by B, B and B. So that we will have cot alpha dash x, cot alpha dash x equal to O by B, O by B. So, this is phi 1 and therefore, this is phi 1, this is phi 1. So, O by B happens to be sin phi 1. So, we have O by B sin phi 1 multiplied by cot alpha dash O plus cos phi 1 multiplied by sorry, just a moment. Since alpha dash x is kept here, it is equal to sin phi alpha dash O, it will be minus cos phi 1, which is L by B, cos phi 1 into tan lambda dash. Okay. So, I am sorry, there is a change in this particular expression. So, I will cut this out as well, and we have this relation existing, cot alpha dash x is equal to sin phi 1 cot alpha dash O minus tan lambda dash cos phi 1. Just a minute, is not that correct? The same? Okay, let me do that. Okay. So, cot alpha dash x is equal to sin phi 1 into cot alpha dash O minus cos phi 1 into tan lambda dash. This is correct. This one is correct. So, what did go wrong the last time? Last time we had a change in sign, I think only. We had only a change in sign. Okay. So, everything is all right now with the cancellation of this expression. So, please pardon me for the change, but now we are sure that we have got the correct result. So, last of all in this particular section, let us do this ourselves completely, that is finding out cot, the value of cot alpha dash y in terms of cot alpha dash O and tan lambda dash. So, this would mean that we have this sort of relationship. This is our tool. So, this will give us good practice. Let us see. I have alpha O dash, I have alpha y dash, and I have tan lambda. So, the triangle that I have to draw will be essentially having machine transverse plane, it will be having auxiliary orthogonal. So, auxiliary machine transverse plane, auxiliary orthogonal, and this one. So, if I move down this way and if I move down this way, I will be coming to this particular distance down this way. So, let us name them as back and L and O. What will be this angle? This is phi 1, end cutting edge angle. So, in that case, let us quickly write the relationship that we can establish. L tan lambda dash, we have gone down this way, now we will go down this way, plus O tan, what do you call it, tan, I am sorry, what is this? This one must be the eraser, yes. If you kindly remember, we have to use cotangent here. So, let us use that. Cot alpha O dash equal to, what is it equal to? This transverse direction we have B cot alpha y dash, and therefore, if we divide it by B, so we have cot alpha dash y equal to, what else do we have here? Right, L by B. Since this is phi and this is a right angle, no, that does not seem to be a right angle. Yeah, this is a right angle, this is also a right angle, and this is phi, right. If this is phi 1, this must be phi 1. So, this is our angle of interest. So, if this is phi 1, L by B is nothing but sine phi 1 into tan lambda dash, this term, plus O by B therefore, is cos phi 1 into cot alpha dash 0. Hence, we come to the conclusion that this expression given here is correct and we have derived it. So, after this we will also have some discussion on another system which is used for grinding of different tools, which is called the maximum rake system, and after that you will be having full confidence to convert from one system to another. In the next lecture, when we are going to discuss with different types of tools, we will look at these tools in the light of the different angles that they bear on their different faces. For example, if we look at a drill, we will try to see which one is its rake surface, which one is its clearance angle, clearance angle, which is its inclination angle, what is its principal cutting edge angle, how many cutting edges it has in the first place, etc. So we are going to look at different tools like drilling tools, milling tools, and so many other tools are there. Okay. So with this we come to the end of the fourth lecture. Thank you very much.